In this lecture, we are going to study the various tests for divisibility. So sometimes it is interesting to note whether this number, let's say 10, is divisible by 2 or 5 or 3 or not. So it's okay that we can find whether 10 is divisible by 2 or not, but what about 128 is divisible by 4 or not? So in tests for divisibility, we're going to study its particular method or a test to find out whether a particular number is divisible by another number without actually dividing and should be faster than the actual division. So it's very important that we are not going to actually divide the entire number by a particular number, and this method, this test should be faster than the actual division. If at all we need to divide a little bit, it should be a bit faster than the actual division. So we're going to also study that this test for divisibility is very useful to carry out prime factorization, divisions, and determining whether a number is prime or not. So let's start with the first one, divisibility test for 2. So how do we come to know whether a number is divisible by 2 or not? So let's write down the table of 2. So we know 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10, 2 sixes are 12, 2 sevens are 14, 2 eights are 16, 2 nines are 18, 2 tens are 20, 2 elevens are 22, and so on. So if you look properly, if the last digit is either of the following 0, 2, 4, 6, 8. So where you can see the last digit is 0, over here the last digit is 2, over here it's 4, over here it's 6, over here it's 8, or in other words it's an even number, then that number is divisible by 2. So just write, let's say 8 over here and write whatever you want to write, like 7 and 6 and 1 and 5, as long as the last digit is 8 or any even number. This number is going to be divisible by 2. In other words, if you divide this number by 2, you're going to get a remainder of 0. So this is the first test for divisibility, and that is for 2. In order to find whether a number is divisible by 5 or not, its last digit should be either 0 or 5. That means 5 ones is 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, 5 fives are 25, 5 sixes are 30, and so on. So if the last digit is either 0 or 5, so 25 is divisible by 5, 125 is divisible by 5, 4125 is divisible by 5, and if a number also ends in 0 like 60 or 360, it is still divisible by 5. But if I suddenly write 2 behind it and the units place becomes 2, then that number is not divisible by 5. So if you divide this number 41,252 by 5, you're not going to get a remainder of 0. Then we have divisibility test for 10. If the last digit is 0, then and only then that number is divisible by 10, because we know the table of 10 is 10, 20, 30, 40, 50. So the last digit is always 0. So if a number has a last digit of 0, then that number is always divisible by 10. Then we have divisibility test for 3. This is not that simple, but still it's simple enough. If sum or the total of all its digits is divisible by 3, then the number is also divisible by 3. For instance, if I take, let's say 87, and if I want to know whether 87 is divisible by 3 or not, just add the digits 8 plus 7, and we know 8 plus 7 is 15, and we know 15 comes in the table of 3. So this number 87 is also divisible by 3. In fact, you can just continue with this. 15 is also made up of 1 and 5. So if you add the digits, okay, I don't say that 1 plus 5 is 15, but if you add the digits, 1 plus 5 is 6, and the 6 is also divisible by 3. So this 87 is also divisible by 3. But if I suddenly write this as 187, and if you add the digits 1 plus 8 plus 7, and this time we get a 16, and since 16 does not go in the table of 3, 187 is also not divisible by 3. And in the very same manner, we have divisibility test for 9. If the sum or the total of all its digits is divisible by 9, then the number is also divisible by 9. For instance, let's take 87 again, and we know 8 plus 7 is 15, and we know 15 does not come in the table of 9, so 87 is also not divisible by 9, since 15 is not divisible by 9. But let's take 999. So 9 plus 9 plus 9 is 27. And again, we can add 2 and 7 if you really want, and we get a 9. And since 27 or 9 both are divisible by 9, 999 is also divisible by 9. Let's take another example. Let's take 3, 6, 36. So 3 plus 6 is 9, therefore it's divisible by 9. Therefore 36 is also divisible by 9. So the divisibility test for 9 and 3 are almost similar. Then we have divisibility test for 4. If the last two digits are divisible by 4, remember the last two digits are divisible by 4, then the number is also divisible by 4. For instance, we know 36 comes in the table of 4. It's divisible by 4. Then 36 is divisible by 4. 636 is divisible by 4. 8636 is also divisible by 4, because we are only concerned with the last two digits, not the other digits. So if this last two digits go in the table of 4, then whatever the number is, that is also divisible by 4. But sometimes, let's say the last two digits are 92 and the previous digits are 3392. The 3392 is the number, and if you do not know 92 goes in the table of 4, you can just divide 92 by 4 instead of dividing the entire number. So 4 2s are 8 and 4 3s are 12. Yes, the remainder comes to be 0. So since 92 is divisible by 2, we can say that 3392 is also divisible by 2. So this is very handy when there are big numbers, and if you want to know whether it is divisible or not by 4. Then we have divisibility test for 8. If the last three digits, hundreds, tens, and units, are divisible by 8, then the number is also divisible by 8. For instance, if the last three digits are 163, I don't know, but let's say 163. Do they go in the table of 8? The answer is no, they do not go in the table of 8, because this is an odd number, and that is not divisible by 2 itself. So if it is not divisible by 2, it's not going to be divisible by 8, and therefore this number or any other number is not divisible by 8. But let's say if we have 144 and we have 5 and 6 in front of it, 65,144, and we want to know whether it is divisible by 8 or not, then just look at the last three digits and just divide them by 8. So we know 8 1s are 8, 8 2s are 16, so we have 8 1s are 8, and we have 8 8s are 64. It is perfectly divisible. So 65,144 is also perfectly divisible by 8. So remember, divisibility test should be a faster method than the actual division. And we are not concerned with the quotient, we are just concerned with the remainder. And finally, we'll have the divisibility test for 11. Now this looks to be a little bit complicated, but it's not so. If the difference of all the sum of odd digits, and the sum of the even digits is either 0 or a multiple of 11, then the number is divisible by 11. So what is the meaning of all these things? So let's take an example of 121. So this is the first digit, units place, then we have the tens place, then the hundreds place. So this is, let's say, the odd digit, this is the even digit, this is the odd digit. So add all the odd digits together. So we have 1 plus 1, and that is 2. And we have only one even digit, so that is 2 itself. And you sum all the odd digits, you sum all the even digits, and then you find the difference. So a bigger number minus smaller number, or the equal numbers are 0. So 2 minus 2 is 0. And if you get either a 0 or a multiple of 11, then the number is divisible by 11. So 121 is divisible by 11. Let's take another example. Let's take 154. Okay, so 1 plus 4 is 5, and this is the only number, even number. 5 minus 5 is 0. So 154 is also divisible by 11. Okay. Then let's take 1331. So add all the odd digits together. It's 3 plus 1, which is 4, and the even digits 1 plus 3, that is also 4, and you get a 0. So if you get a 0, or if you get 11 or 22, then that number is divisible by 11. You can have another way out. Let's take a 154 again. And if you write a plus 1, minus 5, plus 4, you get a 0. So you get that this number is divisible by 11. I hope you understood this. Thank you for watching.